So it is my great pleasure to welcome Dr. Bill Rand. He's an associate professor of marketing at the Poole College of Management. He has a PhD in computer science and is really an expert in today's topic of discussion, which is big data analytics and machine learning. Just a little bit about myself too. I'm Rishika, Dr. Rishika, and I'm also an associate professor at the Poole College of Management. We're also joined as the host of the webinar by Allison Anthony, who's moderating or managing the webinar. So just wanted to thank Allison for that. Thank you, Allison, for doing that. So what we are doing today is we're going to have sort of a discussion format where I have an easier job where I have a set of questions that I want to learn about big data analytics and machine learning. So what I did was I kind of, created the whole list, and I'm going to go through my list of questions, and Bill is going to give his insights on all of those. And also, as we go along, we're going to take mini breaks, and we will, open it up for questions. If you have questions, you can type in the chat as we go along, things that you want to know about. We wanted to make sure that we talk about those things as well. All right, so Bill, do you want to say a few words before we get started?
Sure, I'm glad to be here. I'm very excited to talk about machine learning and marketing analytics in general, right? But I think this should be a very interesting discussion. And I guess the one comment I would make is I very much want to be driven by the questions and comments that come in from the audience. So if you're following along live at home, as they say, right, please feel free to type in some comments or questions directly into the chat or the Q&A, and we can field them from there for sure.
Wonderful. I also wanted to mention that Bill actually leads the Business Analytics Initiative at the Poole College of Management. So we're also hoping to learn something about that as well, because we do some really cool stuff at Poole College. So as we go along, we'll also be talking about that. All right, so we're going to warm up a little bit, which is we're talking big data analytics and machine learning. So I guess the very first thing we want to really know is big data. It's a word that everybody throws around, and I feel half the people who say it really don't know what is big data, right, Bill?
So yeah, so I definitely think that's the case. And in fact, I think that the vast majority of applications or companies out there promoting big data are probably just using it as a buzzword, right, to a large extent, which is what it is. But it's good. Yeah, I think big data is an important point of transformation that's happening in the business world as we see around it. To me, just to kind of dive in, right? Big data often gets a lot of attention from the word big, right? But I think that might be the least interesting part of it, right? So, there's an old IBM definition that kind of talks about big data through the lens of the 3 V's, which is volume, velocity, and variety. And I honestly think that the variety aspect is the one I find the most interesting. If you look back historically at the way decision-making was done in the business world, it was all about what data do we already have that's collected in exactly the right format that we need, right? And then trying to figure out what we could do with it. And so as a result, you saw people paying attention to things like total number of sales per store, right? Which was already in a structured format, right? But variety means that we can now look at data that's not stored in that format, right? So we can look, for instance, at text analytics. We can look at social media data and what people are saying there and transforming it into data that we can take action on. If we're running a call center, right, we can look at text-to-speech translation and then analyzing the data that comes out of it. If we're working at any kind of imagery, right, we can start to analyze that image-based data. And that ability to transform unstructured data into structured data, I think, is one of the most important parts of the data revolution and the big data transformation that's going on around us. And that's really kind of the crux of what will transform companies' decision-making processes in the future going forward.
Wonderful. I think that answer taught me so much that I don't think I could have gotten in a class. So thank you so much. I actually was taking down some notes as well. I think that's absolutely great. And you touched upon this notion of structured versus unstructured data. And I kind of got that, but I feel like maybe you could add one or two lines specifically. What's the main difference, would you say, between those two? And I believe we do at the Poole College, work with unstructured data as well, right?
Yeah, we do a lot of work with unstructured data, and specifically within the business analytics initiative. And potentially I'll highlight as we go through a couple of examples later on. Yeah, the difference, to get back to the first question, the difference between unstructured and structured data. Structured data is basically anything that is already in some sort of structured format. Usually we're talking about a relational database here, right? Where you have rows and columns, right, that describe the activities of a business or operation, right? Unstructured data is essentially data that doesn't have a structure like that, right? It's data that's been accumulated. You might know what it's relevant to, you might know what it's related to, right? But you don't necessarily have any way to directly draw insights from it, right? And so a lot of what we've been playing around with, and what a lot of machine learning tools are doing recently, is being able to take unstructured data and transform it into a structured format, into a format that is more easily accessible to making decisions, essentially, about the business processes.
Wonderful. I'm glad you touched, you brought us along the way and into machine learning right away, and which is where we wanted to go, right? So machine learning is another word that gets thrown around so much, right? Everybody's talking about it. You go to practitioner conferences, you go to academic conferences, and all of the big companies are investing big time into it, and have done it for the last 10, 15 years, but now is the time where it's really coming together. So tell us about machine learning in general first. What is it, right? So as a layperson who does not know what machine learning is about, how do I think about it?
Yeah, so machine learning is basically, the idea that you can take a data set from a company or an organization, or about anything. Honestly, it could be, data from the grades of your children in school, right? And you run some sort of tool over it that is attempting to learn patterns in the data. And can I share screen? Is that okay, Rishika?
I think we should be able to, right, Allison? I think that should be enabled.
Let me see if I can do that right now, right? Because I think that there might be a good way I can describe this. Let me get down to the
That would be great.
I want to do, well, I say it's always tricky switching between screens on the fly.
Yes, it always is.
Let me pull this one over here and we'll go like that. Okay. So if I do that, hopefully you're seeing that now. Is you seeing it?
We're seeing that you started it, but I'm not yet seeing the screen. Oh, there it is. Now.
Okay. This is a pipeline that I often like to think about when discussing machine learning and analytics in general. But the reason why I'm going to bring this up right now is because I think machine learning plays a critical part of this. So if you think about it, on the bottom end of the data pipeline, we have raw data. These are essentially unstructured, or maybe structured, but just kind of collected in groups of data that don't really have a particular application to a particular domain area. If we move one level up, we get to information. Information is essentially data that has been collected into pools of information that are relevant to the topic that we're looking at, right? Once we move beyond that, we start to think about knowledge. And it's this translation between information and knowledge that really is where machine learning comes in. Because knowledge is essentially identifying patterns in the data that are useful, right? That are predictive or descriptive of something occurring in the information. And then, of course, the most critical part, and something that we're teaching a lot in the Masters of Marketing Analytics, is how to take that knowledge and now transform it into wisdom. And wisdom is knowledge that has been applied to a particular business problem. So machine learning, and I'll be referencing this a lot during today, so I wanted to bring it up early. Machine learning is really this transition from information to knowledge, right? How do we take data that has been stored and collected in some particular way, and start to use it to understand the patterns that are present in it? So, a classic example of this, that has been applied a lot is shopping cart analysis. So as people are going through and making purchases at a store, often you'll see those little loyalty cards that you get, right? And we can track now the purchases that you're making at a particular time to you as an individual, right? And then over time, we can learn that pattern of behavior, what you're likely to purchase on what days, at what times, right? Maybe time of the year even, right? And then we can learn a pattern for other individuals like you. And then what we can do is we can start to identify promotions that might work, right? So, hey, on Wednesdays, you normally buy a 12-pack of beer for the weekend, right? Here's a coupon to give you $1 or $2 off, right? To try and encourage additional purchases in that way, right? And that's really what machine learning is about. It's about learning those models of behavior, about learning those patterns that are present in the data. And there are a lot of different tools to help you out with that. Some as simple as linear regression, right? That has been used for years, all the way up to things like deep learning nets and random forest and causal forest that have become more advanced analysis tools nowadays.
Wonderful. Thank you so much. We touched upon so many important things out there. I'm having a hard time even keeping track of it. So we have a question here to address. I was gonna ask that a little, a while from now, but we can take it now, I think. So James Daly has a question. Which market or industry do you think will be most impacted from machine learning and organizing big data? I think that's a great question.
Yeah, that's a really good question. And quite frankly, I don't know if there's particular industries that are more ripe for the approach. I would say, though, that that are most impacted. I would say that the industries that are probably most likely to be impacted, right, are those that have data that hasn't traditionally been stored in these structured formats, right? Historically, a lot of the old approaches, right, so of analyzing data relied upon the data already being in an easily analyzable format, right? So for instance, something like the accounting industry, right? They already have a lot of their data stored in structured formats. That's not to say they can't improve, right? They can get more and additional insights, right? But I don't know if really that's going to dramatically change the industry too much, right? But whereas something like, an apparel manufacturer, for instance, right? As they get better tools to be able to match the particular shape and description of dresses or shirts or ties or whatever to particular desires that people might have, right? They might see a much larger change. One kind of out there aspect that I think is that I've been working a little bit with myself is the law. I don't know if you call them a market or an industry, but I think there's a ripe aspect is legal analytic tools that will help lawyers make better decisions about what kinds of arguments to pursue, what kind of court cases to look at, right? Things like that. And I think that's an area that has not been explored at all, but some of our friends down at Campbell Law School right now are actually exploring those topics themselves. So, yeah.
Wow, that's just crazy. I'd never thought about legal analytics at all. But now that you say that, it sort of makes sense. It should be possible to apply that, right? That's amazing. And I was, as you were talking, and just to kind of, take it to a lighter note, because, some of my students are here in the audience as well, just for them. They know that I always like to put in a lighter note in if I can. So I'm kind of thinking of that. What's a Tom Cruise movie where he walks into, right?
Minority Report? Yeah.
Yes, yeah. So we haven't seen that yet where you walk in, but are we getting there is what I wanted to ask.
Well, I mean, there's two aspects of that movie, right, that are probably relevant to the discussion. One is the aspect of the ever-present advertising that is in your face at all times, right? And the other is predicting crimes before they happen, right? Yeah. I don't think we're at either event yet, luckily, to some extent. I do think, it's interesting. On the advertising front, I think we are likely to see more and more tailored advertising to our particular interests. Now, whether it'll be as pervasive as it is in the Minority Report, where it shows up and hounds you no matter where it is, I don't know if that's the case, right? There's some good arguments that actually some of the most annoying digital ads actually are less effective, right? Because people just kind of steer away from those products over time if it's too abrasive and too in your face, right? in terms of the criminal predictions, that one, there are a bunch of issues up there that deal with ethics and privacy and concerns. And that's something that we're also trying to address here in the business analytics initiative, right? Like at what point are firms using too much data, right? Are they scaring their customers off because they're actually too predictive about what's going on? And I think part of that is addressing ethical concerns that might come out of that data, but also part of it is even in cases where a consumer might want a particular piece of information, they may not necessarily want to be marketed at directly, right? And so are there ways that you can use insights about your customers without creeping them out, essentially, right? And that's another area of interest to think about as we continue to approach better and better methods of predictive and prescriptive analytics.
That's wonderful. Well, thank you so much for those good insights. And I, at some level, I know I understand the ethics aspect, and I don't want to go to the minority report. But on the other end, it can be delightful, right? I mean, it can delight customers. So there's always that balance. You're losing your privacy, but you can have more fun, I guess. But we'll see how it goes.
Yeah, I mean, one thing I often tell my students in my digital marketing class is that people, to some extent, people will say that they care about privacy or they care about their own personal information. And I believe them, right? But really what's driving them is they don't want to be shocked at the information you have about them or scared by the information you have about them, right? And so if you can present your ads, if you can present your techniques in a way that kind of doesn't seem scary, right? Then they're usually much more amenable to the advertising that you're presenting them with.
That's right. Actually, James has another comment there. If Google could build my shopping list, I don't think I would care.
Exactly.
Yeah. I think a lot of us might appreciate that.
Yeah.
Well, thank you so
Ironically,
much.
Amazon actually has this was something I was going to mention later, right, as one of the applications, but Amazon actually patented a pre-purchase predictive model, right? So they essentially, and this actually happened a while ago, but their argument is they believe they have a tool that actually knows what you're going to buy before you buy it, right? And so if you ask how are they able to do all these ridiculous same-day shipping, 1 hour shipping, right? All this crazy stuff, it's because of these algorithms, right? They're able to make sure that the right goods are in the right places at the right time so they can actually get them to you as quickly as possible, right? So in some ways they are building, Amazon at least is building your shopping list and has said that already, right?
Wow, that just blew my mind right there. I did not know that. I honestly did not know that. And, I wish they would just tell me, because then I can stop browsing around and just order, and they can say, you're likely to buy this. And I just, okay, if you know it, you probably know me better than I do.
All they're really waiting for is you to click a link saying that you're ready to buy, right? Like all the rest has already been done.
That is wonderful. That's crazy in a way, but it's also wonderful. All right, so getting a little bit more technical here, right? So one of the questions that I have is, what types of software generally are machine learning? So if somebody wanted to, let's say, get started on learning about it by themselves, if you had some insights on that.
Yeah, so this is an evolving market, right? Really, to a large extent, and historically, right, most machine learning was done by computer scientists who were writing code from scratch, right? And I'm not even talking about today's languages like Python R, but from in C++ and Java and stuff like that, right? Nowadays, more and more of it is being done in kind of these standardized data science formats, right? So Python and R are probably the most dominant languages there, right? And then there's usually some sort of data science workspace that may wrap around that. Conda is a very popular one in that space to kind of give you access to all your tools in one spot. But that's not the only place machine learning is being done now, right? That's for people who are really building brand new machine learning tools, right? That haven't really, either haven't been developed before or haven't been applied to the data that you're interested in looking at again, right? If you move one level up, right, there's a series of tools now that are building in machine learning, and quite a few of them to that matter, at a more point and click type interface, right? So SAS, for instance, has some of these in them. JMP, they're kind of is even more graphically oriented, right? And then if you kind of get but most of those still require like some sort of data manipulation, data input, things like that. Finally, if you go all the way up, right, you have things like Power BI and Tableau, right, which are almost entirely click driven, right, interfaces that allow you to do machine learning on large scale data sets that you can bring in to what you're analyzing. And but some people are still comfortable in tools like Excel, right? And so you're seeing more and more machine learning tools rolled into something like Excel, right? That allow you to bring them. In fact, I talked to a company who will remain nameless, as you'll find out for reasons, who said that they basically were using Tableau to basically identify which data they wanted, and then dumping the data to a CSV file, which they were then reading into Excel, and they would actually use Excel to do all their analysis, right? So they were using this fancy, like really state-of-the-art data analysis and machine learning toolkit that is Tableau to essentially do nothing but identify the data that they could easily analyze in Excel, right? Which I found as a very interesting story, let's put it that way.
Actually, that is so interesting, and just kind of related to that, do you think that would, in general, it might be more of a phenomenon than just that particular specific thinking, because a lot of managers are not trained in these tools. So maybe the company buys it, but because they don't have the training, they're kind of getting these shortcuts to do what they can do better.
Yeah, and there's a host of I think we're going to see, let's put it this way, a host of new providers that are trying to make this even more automated, right? They're trying to build kind of analytics as a service, essentially, or machine learning as a service, right? Where you basically say, here's some data, here's the question I have, right? And they have some sort of limited format of questions you can ask, find the answer, right? And these tools will just do it. One Data Robot, which has become more and more popular as a partnering platform in this space, seems like it is headed in that direction potentially, right? It still requires a little sophistication, but it is headed in that place of trying to help people automate a lot of these machine learning and analytics tools, so that they don't have to redevelop them every time they have a different question about the data they're looking at.
Wonderful. Well, thank you so much for that. And a lot of my questions, I feel like I can, move on because we've been answering them. But I think it's time to just kind of make sure there are no other questions. I don't see any questions, but I also want to take an opportunity here and open it up for questions. Any of the attendees, if you have questions, guys, I'm going to give you about 30 seconds to type in your questions, and then we can take those. Anything that comes to your mind about machine learning, big data, or the things that we've been talking about, because I can go on and ask so many of my questions, but I want to make sure that I want all of the participants to also ask their questions.
You know what, Rashika, why don't, maybe as we're doing that, maybe I can provide a couple of examples of machine learning problems that we've worked on here in the BAI. And if people have questions about any of those, maybe that'll kind of give people more of a taste of what we're talking about.
That sounds great. That sounds wonderful.
Let me bring up another slide I have on that. Okay. Everyone see that okay now?
Not yet, but I think it's going to appear. There it is. You can see that.
Is it cutting off at the sides, or is it?
Yes, I'm not sure why it is, but it is.
Yeah, hold on a second. Let me do something real quick. I'll reshare that and see if we can fix that just quickly.
Okay.
Stop share. I think I need to start the presentation before I share is the problem. There we go. Is that better?
Just give us a second. It's just kind of, I think it's just starting to share. Okay, there it is.
Okay, cool. So, we've worked with a couple of different organizations. Actually had a call this morning about another organization that's looking at working with the BAI to use machine learning to solve their problems. And a lot of our emphasis, as I kind of highlighted at the top, is on this kind of translating unstructured data into structured data. So in this particular program, we were working with the Clinton Health Access Initiative. In fact, we still are, who approached us early on in the pandemic about how to determine in real time the best solutions to COVID-19 that were being discovered and understand what the best practices were for them to prevent the growth of COVID-19 and its reoccurrence. And in particular, they're interested in sub-Saharan Africa. That's a place where they work quite a bit. So in partnership with them over the last year and change, we've kind of developed a toolkit that pulls in data from a variety of sources, mainly mainstream media, right, sources, as well as scientific reports, right, and scientific publications, but also Twitter and Google Trends and some other places like that. And we've utilized all that to create a dashboard to inform CHAI itself, the organization, as well as any other stakeholders about what's going on with COVID-19 most recently, right? In particular, what they're interested in is, so CHAI essentially helps connect funders, people who have money to potentially solve problems with COVID-19, with organizations that need that funding. And so CHAI is using this dashboard to try and highlight where those most pressing problems are and to connect those problems together, right? So what is machine learning doing in this context? The machine learning is really taking that raw, unstructured data about that are just news articles about COVID-19 and trying to identify which are the most important and pressing issues that are facing the questions that CHAI has, right? So that they can put together almost a newsletter, if you will, on a regular basis to understand those problems. So that's one example, and a similar example that I want to talk about that maybe has a little bit different of an impact. If I can, my stuff clicked on something. Trying to click. There we go. Okay. There we go. Is with the American Codings Association. So the American Codings Association essentially works with all the paint companies in the United States. And what they were interested in is, are any of the chemicals that our companies using, do they have potential issues that we would like to know about with regards to health or the environment or anything like that that we're not already aware about, right? And so we worked with them to build a dashboard to kind of monitor those conversations, monitor again, health and environmental studies, legislative actions, anything like that, to try and provide them with some insight into which of those chemicals could potentially be a problem. For those of you who remember, there was an issue with like BPA a while ago, right? And how it had to be removed from a lot of products that were out there, right? And the idea was, could we avoid that? Could we identify, oh, there's a problem here that's now being discovered by scientists. We need to rethink our chemical solutions to these problems, right? And that's really the goal that they were looking at. And so we built a dashboard for them. And again, the AI tool essentially took this unstructured data, tried to identify patterns and trends around particular chemicals and determine whether or not they were of issue for the companies we were working with. So that's two quick examples of things we've worked on in the past, and kind of give you some insight into the way AI is helping companies make better decisions nowadays.
Thank you. I think that was very insightful. And we also have a question. But before I go to the question, I'm going to ask my question, and I'm going to forget it otherwise. And one thing that I've always been curious about is that machine learning and AI are often used together. Is there a difference, or are they interchangeable, right?
So for the vast majority of business applications, there's little difference between those two terms. Generally, I would think of artificial intelligence, I would think of machine learning, I should say, as a subset of artificial intelligence, right? So machine learning is specifically about learning patterns and data that already exists, right? It actually used to be called pattern recognition and machine learning, right? So that kind of gives it even more of an obvious kind of statement to it. But artificial intelligence is more general about how do we allow computers to think and act like humans, or like intelligent beings, I should say, not necessarily humans, right? How do we give them the insights? And so there are some parts of artificial intelligence that aren't related to machine learning. These are, things like how do we, give a robotic interaction an emotional conveyance to it, right? So that it not only says the right words, but expresses them in a nice mood, right? Or says them in a way that is convenient to the person around them, right? That's not necessarily a machine learning question, right? That's more of an artificial intelligence question, right? And to some extent, some of that stuff's relevant for businesses and organizations, but most of the times, I would say 90 times out of 100, or even 95 out of 100, that a business has a problem that they want to solve with artificial intelligence, what they really mean by that is machine learning. They want to look at the patterns they're looking at, right? Historically, the more general artificial intelligence question was, given any possible sensors and data that a computer can see around the world, can it structure that world and interact with it in a structured way, right? But that specifically, right, that's kind of a general generic type of idea. ML, machine learning, is a specific idea, which is, what is the patterns that we're seeing in the data behind us that we've collected? How predictive is that? And will it allow us to take action to alter the future in some way, right?
That's
and
wonderful.
so AI and machine learning often overlap in many respects, and in particular in most modern business domains.
That's great. And just to kind of put in a, funny anecdote here, which is, of course, all of us are familiar with Alexa, right? So Alexa is a family member in my household for sure. And she's gotten so smart over the years. But I just recently learned, because I grew up in India, and I was just kind of testing her out if she can speak the language I grew up with. And I just asked her, can you? And she said, yes. And I was able to just talk to her in the language I grew up talking in. It was just a delightful experience to experience that. And that's my AI experience just today, which was fantastic.
Yeah, that's fantastic. Yeah.
All right, we can take the question. Saurabh has a question. It's a long question. He says he's a master's student in healthcare data analytics at University of Arkansas for medical sciences in Little Rock, Arkansas. Thank you so much, Saurabh, for joining us from there. I'm currently taking machine learning, big data classes in R, SAS, Python, and SQL. How and where do you see the healthcare industry and business industry working together on big data or data sets in the next 10 years?
Wow, that is an absolutely fantastic question, Sarah. Thank you so much for it. And that's actually something I'm really passionate about and interested in. That's part of the reason why we're working with Chai right now. I honestly think that the problem facing a lot of the healthcare industry right now is a deluge of data. We have more data than ever before about our patients and about disease states and gene and the personalized medicine that we could be presenting to our patients. I think this is an area where healthcare industry, business industry, the IT industry in particular, could be working together quite a bit in the next 10 years, right? What I would love to see is the development of kind of a system of tools, right, that would allow you to kind of bring all this data together, of course, respecting whatever privacy laws are necessary to respect, like HIPAA, right, and things like this, to be able to give anyone the ability to access the information that they need at that point, right? So you can imagine a modern healthcare facility, right? A large healthcare facility, let's say a hospital or something like that. A lot of what we talk about there is resource needs, right? Which is, do we have the beds, right? Especially right now with COVID-19, right? Do we have the ICU beds that we need for the patients coming in, right? But almost an important question, a question that's not really talked about, is information needs. Do we have the right resource and the right information co-located in the right place so that the right medical provider can provide the right solutions at that time, right? And so really, I think that this ability to bring that information together and make sure it's presented in a way that doesn't overwhelm the healthcare provider is critically important. You don't want them scrolling through 10 pages of health logs, right, for a particular patient to find the information they need right now. A lot of the new AI techniques are really good at taking large amounts of data and figuring out, based upon observing interactions with that data, what pieces of information does that doctor need right now, right? So having tablets and tools that could adapt to a particular healthcare provider's uses and how they use that data, I think would really revolutionize healthcare. Now, that's on the healthcare provider aspect. I think the other aspect that would be very helpful is the advent of precision medicine, right? And this is the idea that we need to be able to take into account the variety of the human experience when deciding how we're going to treat a particular patient, right? So much of medical research in the past has been done based upon kind of a average effect across a particular set of groups or individuals. And being able, I think what you're going to see is you're going to see an explosion of firms that are trying to target and provide specific recommendations for that patient right there. Quick example, I'll show it off. I wear one of these little doodads on my wrist all the time. This is called a Whoop strap, W-H-O-O-P, if you want to look it up. It's constantly monitoring my heart rate, my respiratory rate, and my heart variability, which is the distance between my heartbeats, the average amount of time between my heartbeats, right? It then uses that every night to provide me, or actually in the morning, to provide me with insights about how well I slept the night before and how well I recovered from any exercise I did the day before. I can then use that information now actionably to make a decision about how much I'm going to train or exercise that day, right? And how much sleep I need to get that night, right? Based upon the information I have. So in some ways, my decision about whether or not to sleep in, I now let be data driven. I don't just wake up and be like, I feel tired, I should go back to bed. I look at my Whoop data and I'm like, hey, do I need another hour of sleep? Well, maybe, then I'll turn off the alarm clock, right? But maybe I don't. Maybe I'll get out of bed and go for a 20-mile run. I haven't gone for a 20-mile run in a long time, but maybe a 6-mile run. I've done that recently. So
that's wonderful. I mean, I'm just kind of thinking, I don't sleep half the nights. I don't know what my Whoop monitor or strap is gonna tell me. I might never make it to school.
Yeah.
That's wonderful. We have another question. It's from Anonymous, but it looks like a good question. So while data analytics is interesting and a growing need for business, I'm afraid of the workload life for data analysts. The recent article on 90-hour work weeks of Goldman Sachs employees makes me want to avoid the whole industry. So is there or will there be enough graduates to meet the demand?
That's a great question. I think there's two answers. I would say. I would say, first of all, as though it might make 90 hours work weeks at Goldman Sachs look scary, it also means that there's going to be a lot of demand and a lot of salary increases for those who are interested in this space, right? On the other hand, I do think that we are trying to increase the amount of graduate, and there's been a recognized concern. That's why here at the Poole College, we're continuing to increase the programs that we offer in this space. The other aspect I would say is that as we increase the automation of data analytics, there's going to be less requirement. It's going to take less time to do the same amount of work, right? So that 90-hour work week is probably going to go way down as we have more and more tools, like some of the more fancy tools being rolled into Power BI, Data Robot, which I mentioned earlier, right, and things like this, which will allow those people to spend less time cleaning data, building their machine learning models, putting all that together, and spend more time creatively thinking about what analytics questions should be asked, right? And that's really, we should be automating as much as possible the data analytics aspect of this, right? That is really the part that doesn't really require much human intervention, right? And we should allow the marketing analytics person, the business analytics person, the risk and analytics person to spend more time thinking about what are the questions they actually need to ask to make a better decision, right? And I do think that we're going to be headed in that direction. will there still be some jobs out there that are 90-hour work weeks? Inevitably, because someone's willing to do it for the pay that they're offering, right? There's no way around that, right? But there are plenty of places where I know I have good friends of mine who are working as data analysts in industry right now, and they are not working 90 hours a week. So it is quite possible to raise a family, have a normal life, balance your work life while still doing data analytics.
Yes, thank you. I think that was a great answer. I do believe it can be done, especially in the last 1.5 years. I feel like people have learned to work, remotely, and that might be the wave of the future. And that should cut down on the 90-hour work week, at least at some level, right? People, if they're with families, they can be happier and more productive. I don't know. I feel like it should be definitely the work hours should go down, is what I feel. Yeah. So we're kind of getting close to the end of our conversation. I think it's been absolutely wonderful, and I didn't want to take it all the way to 7. I definitely wanted to give more chance for questions, but I do have one last question to kind of really wrap around what we've talked about today and wrap it up in a way that if you were to think about your own goals, right? So you've worked in this field for so long, and I wanted to get that personal insight from you. Mm-hmm. You see yourself, your research going the next 5 or 10 years, and maybe also how you see the field evolving. And I know you've talked a little bit about that, but maybe connect them together and give us a sense of that.
Yeah, I'd say generally, all of my interest in the space, and this actually, it's funny, it goes all the way back to my undergrad days, honestly. Like I remember the application I wrote for graduate school, and in some ways, the kind of the personal statement of what I was interested in hasn't changed much, which is good, right? In respect, it means that I was asking questions back then. There are still big questions now, right? And fundamentally, there's 2 questions that keep me up at night, right? One is, how do people find things out? Sorry, I should phrase it more generally. There's actually a number of questions that keep me up at night. There's 2 areas that keep me up at night, right? So one is with regards to diffusion of information, which I feel is really focused around 3 questions. How do people find things out? What do they do with that information once they have it? And how do they pass it on to others? And in many ways, you could say all of marketing is busy answering those 3 questions, right? To some extent. And then another area that I'm interested in is data-driven decision making. How can we provide tools that help people make better decisions given the data that they have about the decision they're trying to make, right? And I think these 2 areas are kind of intimately linked, right? Which is that if we can study how people are making decisions right now and how they're looking at the information that's coming into them right now, we can potentially start to think about how they could make better decisions in that space and then give them the tools to help them make those better decisions, right? So data-driven decision-making, I think, is intimately linked to the question of information diffusion, right? Now, that's kind of just a brief discussion of what I'm interested in, so you get the context. Where do I want to go with this, and how do I want to use machine learning to make this better? Well, I think one aspect that's really kind of changing and growing in this area is this ability to bring more and more different types of data into context, right? So we talked a little bit about text already in a couple of different contexts. I've been started working on images, right? Can we look at the images that advertisers are presenting to their customers and try and figure out what aspects of those images are making people click on a particular hotel room that they might want to purchase, or look at a particular dress online that they might want to order, right? Is there a way we can change the layout and the aspects of those images to make them more informative for the consumer, to allow them to make a better decision about whether or not to purchase that particular product, right? The other aspect, if you go beyond images that I'm interested in, is video, right? So we know now more than ever that there's more video online. And in fact, images and video on average get 3 to 5 times the engagement on social media that text posts do, right? And so what can we do to make better video, right? And this is not a question that's well understood, right? Like we know a little bit about how content goes viral and how content spreads, but we don't really know is there keys and are there patterns to video content production that is more useful for firms to use, right? And that's another aspect that I'd like to spend more time thinking about and more time examining. And I think the answer to both of those is we got to use machine learning, right? There's literally too much raw data for a human to understand by themselves. We're going to have to use machine learning approaches. And there we get into things like convolutional neural nets and deep learning approaches to kind of boil down those aspects. Now, we'll still need a human in the loop. We'll still need someone to take a look at the analysis that those tools have done and try and figure out what they're saying. But we're going to need to use machine learning to help understand these rich environmental info systems that we're dealing with nowadays.
Thank you so much. I think that's wonderful. And as you mentioned, actually, the images and video, I think that is such a great context. And I'm glad that finally you were able to talk a little bit about that. I think that all of that has such huge power to change people's lives. And I say that from a personal experience, because if I hadn't found certain YouTube channels, I don't think I'd be where I am. I mean, they fundamentally changed my life because you can they really did. And I obviously don't want to go deeper into than that, but I really believe that. And it has. And if we were just kind of sometimes just, we used to watch what others selected for us, right? And we don't do that anymore. We watch what we want to watch. And that is so powerful. And you're right when you mentioned that context. I think that's a great context, and it's a great point to wrap up today's discussion as well. So thank you so much, Bill, for this really enlightening conversation. I personally really did learn a lot. And I'm also going to see if there are any questions, any last call for questions, guys. Oh, we do have another question. So let's take that. Palantir, a data analytics company, bought thousands of gold bars. In data analytics, they say that your predictions will always be wrong, but should be close enough. Should I be afraid about a large market crash or black swan event? How much should I trust data, and should I be scared?
Well, that's a great question. Palantir historically actually has steered away from kind of straight up machine learning approaches and has looked more at kind of rule-based approaches, right? So I don't know if necessarily, that looking at what Palantir is doing is necessarily the best reflection on what we're talking about today. But that's another story we could get into at some point as to what approach is more appropriate here. I am not afraid of a large market crash or a black swan event, right? Like, these things do happen, and we should try and keep in mind. That's actually a really good segue into another comment I'd like to make, is that really is a question of risk. And actually, we're talking a lot about marketing analytics, but another project that we're starting up soon is a risk and analytics degree, right? That will allow you to use data to better assess risk and things like black swan events and other aspects like that. I personally am a big fan of data. I would say you should always trust it. You should be wary about where it's been collected from and who's collected it, and have a really good understanding of all those aspects. But I always think back to this guru of IBM, Deming, who once said, "In God we trust, all others bring data," and that's usually a rule that I live by. So I'm happy to continue to trust the data in this case.
I totally agree. I absolutely agree. I think we have to trust data, and yet, keep that open mind. So I feel like it would be absolutely unwise to not trust data. So I absolutely believe that. All right. Let's see. There are no open questions right now. Any other questions, guys? All right. I'm not seeing any questions. Well, thank you everybody for joining in. We're a few minutes into 7. Oh, thank you. We're seeing. Thank you, James. Thank you for joining in. Thanks, Nathan. Thank you, Saurabh. Thanks, Emily. I feel like we know so many of them too.
Well, thank you all for showing up tonight on a later Tuesday night. But it's been a pleasure talking with you, Rishika. Thank you so much for hosting this.
Thank you, Bill. Yes, I really, really did learn a lot. And thank you so much for indulging all of my questions. I think I did learn a lot. And all right. Good evening, everybody.